Assalamualaikum students. Students, today we are starting, we are doing the ionization energy, the electron affinity, and then we are going to do the delta H lattice, right? In the previous, we have done the delta H formation, delta H atomization, bond energy, and now we are doing the next three. And in the next lecture, you are going to study the Born-Haber cycle. Delta H ionization, it's the same ionization energy of your AS. In ionization energy, Cambridge is not going, I don't think so. I don't think so that the system is going to ask you that define delta H ionization energy. In the last 25 years, there is not such question, but yes, they fully use, the Born-Haber cycle is fully used in the concept-wise in the Born-Haber cycle. Otherwise, like you must know. But the particular definition, I don't think so. I hope that they don't ask you. I'm just saying, I'm not saying that it is not in the course. They can ask you, right? Now, to explain delta H ionization energy, I'm going to share the screen. When I'm sharing the screen, you guys are supposed to like, subscribe, and share the channel, right? इतना तो आप करोगे बेटा अगर मैं पढ़ा रही हूँ आपने क्या करना है जो बताया है ठीक है so come I'm sharing and do your job 1 2 3 yes no it was 3 2 1 look now I'm going to explain delta H ionization energy जिसके बारे में मैंने क्या कहा कि डेफिनेशन नहीं पूछेंगे डोंट वरी बट अगर आप सुनना चाहते हो तो इधर देखो delta H ionization energy it is look I'm telling you do you want to if you want to write just note it down it's the amount of energy needed to remove one electron from each atom of one mole gaseous atoms. Look, amount of energy needed to remove one electron from each atom of one mole gaseous atom. Automatically, they will turn into one mole gaseous unipositive ion. You can also define it this way. It's the energy needed to remove 1 mole of electron from 1 mole of gaseous atom to make 1 mole gaseous unipositive ion to ensure that each atom is losing 1 electron. Now, suppose I'm having aluminium. Aluminium. Now in aluminium, there are 13 electrons. 2 are in the first shell, 8 are in the second shell, and 3 are in the last shell. 2, 8, and 3. Look, when we remove the first electron, after removal of the first electron, the electrons are getting lesser. When the electrons are less, the inter-electronic repulsions are less. As a result, nuclear attraction is more. Look, the protons are not increasing. The protons are same. But electrons are decreasing. Repulsion decrease. Electrons are getting closer to the nucleus. We are getting closer to the nucleus. Nuclear attraction increase. So each successive ionization energy will increase. So if I write the equation for the aluminium, what are the equations? Aluminium gaseous. Let me do it this way. First ionization, then second ionization, then third ionization, then fourth ionization, fifth, and so on, so on, so on, then 13 will come. Okay. So aluminium turning into what? 1 plus. Then 1 plus into what? 2 plus. Then 2 plus into what? 3 plus. Then 3 plus into what? 4 plus. And aluminium 12 plus into what? Aluminium 13 plus. Bare nuclei is left. Now, if we look, more the positive charge, more is the nuclear attraction for the electron. More energy is needed to take out the electron. So if I plot it, if I plot the ionization energy of the aluminium against electron removed. First electron removed, second removed, third removed, gradual rise. After third electron, the fourth electron is from the next shell closer to the nucleus. Quantum shell is changed. Sharp rise. Then fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th. And then 12 and 13. Sharp rise, like we are getting closer to the nucleus, the nuclear attraction increase. So I think you understand, you revise the ionization energy. And the opposite of the ionization energy is what? Electron affinity. You know, if I share the notes with you, this is ionization energy. The successive ionization energy increases, the positive charge increase, more is the nuclear attraction for the valence electron. Electron affinity. You know what is electron affinity? Electron affinity is, you know what is electron affinity? It is the amount of energy needed when 1 mole of electron is added into 1 mole gaseous atom to make 1 mole gaseous uninegative ion. Look, 1 mole gaseous atom, 1 mole electron, 1 mole gaseous uninegative ion. Look, enthalpy change measured when 1 mole of electron is added into 1 mole gaseous atom to make 1 mole gaseous uninegative ion, which ensure that each 1 electron added into each atom. Enthalpy change measured when 1 electron is added into each atom of 1 mole gaseous atom. Like you have 1 mole gaseous atom and you're adding electron into 1 each. So they are turning into uninegative. So the atom attract electron. Why this atom attract the electron? The atom attract because the atom has a nuclear attraction. And the nuclear attraction, more attraction is more. Like for example, It is 1 mole oxygen atom gaining 1 electron. What will fall? O negative. The atom attracts the electron. The atom nuclear attraction. Attract the electron. More attraction, more exothermic. More exothermic. But now, what do you think about? Do you think O negative will also attract electron? Do you think a negative can attract an electron, a negative? No. This shows that when they are repelling, it becomes what? Dinegative. The atom attracts electron, but anion does not attract. The anion will repel. If it is repelled, then how the electron is added? It's by force. It's endo. More repulsion, more endo. Only first electron affinity is exo. The rest are all endo. Right? Now, listen. Suppose it is nitrogen gaining electron, attract, exo, negative gaining electron, dinegative, endo, dinegative gaining another electron, trinegative, much more endo. So electron affinity, only first is exo, the rest are all endo. And what is your explanation for this? That anion repel electron to overcome the repulsion. Energy is supplied, provided. Now, the first is what? Exo. It depends on what? More attraction, more exo. So down the group, you know, number of shells increase. Down the group, size increase. Across a period, size decrease, nuclear attraction increase. Look, down the group, across a period. Down the group, the size increase, the nuclear attraction decrease, and electron affinity is what? Less X. Across a period. Huh? No, it's not good. Across a period, what is happening? Size is getting what? Small. Nuclear attraction increase. Electron affinity is more exo. And you know how the system is going to ask you? Fluorine, chlorine, bromine, it is getting what? Less exo. But if it is carbon and nitrogen, the nitrogen is more exo. Like they're going to ask you this way. They will give you down the group, they will give you across a period. But in the across a period, most of the time, they don't give you across a period thing. They give you the elements, like carbon and nitrogen and oxygen. Which one will be more exothermic? Oxygen, that definitely. Because oxygen is smaller than nitrogen. Okay. Now after, but okay, wait. First see the notes so that you know that everything is there. Like this, I've discussed that how they are repelled and attract. Only first electron affinity is exo, the rest are endo, and these are explanation. This is down the group, this is across a period. I think you understand. Now, delta H lattice. What is delta H lattice? You know, delta H lattice is what? This much I'm going to copy. delta H lattice. What is delta H lattice? Enthalpy change. Enthalpy change measured when, under standard condition, when 1 mole ionic lattice, आप कहोगे ऊपर लिखा है फिर क्यों लिख रही हो, आदत है. Enthalpy change measured when 1 mole of ionic lattice is made from gaseous ions. यानी आप आयन से लैटिस बना रहे हो, ionic bond बना रहे हो. What is ionic bond? Electrostatic forces of attraction between cations and anions. The ions attract. When they attract, energy is released. That energy released, kilojoule per mole of the ionic lattice, is called delta H lattice. Now, पहली example अगर मैं लूं, as usual, NaCl, like chemistry or NaCl. Always, whatever you teach, if it is something ionic, there would be NaCl because it's available on your dining table too. Okay, now NaCl, suppose 1 mole NaCl solid ionic lattice from what? Gaseous ions. Sodium ions attract chloride ion. Delta lattice of aluminium oxide from what? To aluminium ions attracting trioxide ions. Delta H lattice of calcium, so untidy, sorry. Delta H lattice of calcium hydroxide. It's made from what? 1 calcium ion. And how many hydroxide? 2. Look, calcium with 1 hydroxide and another hydroxide. Inside the hydroxide is covalent, but between hydroxide and this is what? Ionic. And delta H lattice is the measure of the strength of this bond. Stronger the bond, more exothermic is delta H lattice. Now, delta H lattice of suppose magnesium phosphate. Solid from 3 magnesium ion and 2 phosphate ion. So you are actually making 1 mole of ionic lattice from what? Gaseous ions. Cation attract an ion. When cation attract an ion, these are electrostatic forces. It depends on what? Delta H lattice. Delta H lattice. You can even say all electrostatic forces. Cation attract an ion, cation repel cation, anion repel anion, whatever are electrostatic forces. These forces depend on 2 things, charge and size of the ion. Smaller ion with high charge. Smaller ion with high charge result into stronger electrostatic forces. So more exothermic, delta H lattice, if it is a lattice, it's attraction. Now, delta H lattice depends on what? Charge of ion and size of ion. Charge of ion and size of ions. Now, we can even say charge density. What? Charge density is what? Charge divided by size. If the charge is more, charge density is more. If the size, like if I relate it to the size, now size should be what? Small. For higher charge density, size small, charge more. So which type of ions? Smaller ions with high charge. Smaller ions with high charge result in stronger ionic bond more exodelta H lattice. But when you are comparing, you know what are you supposed to do? Look, it's always exothermic, stronger ionic bond, more exothermic. It depends on charge and size, high charge, small size, high charge density. But when you are comparing this way, which one has more magnitude of delta H lattice, barium sulfide or barium oxide? Now, what are you supposed to do? First, write about charge and size of both ion. Look, the barium is same. Where is the difference? Sulfide and oxide. Yes. The barium is same. Where is the difference? Sulfide and oxide. So you are supposed to write about the charge and the size of the ion. Then write about the attraction between the ions, stronger or weaker. Then talk about the magnitude of the delta H lattice. For example, suppose if I'm comparing the same situation, the barium oxide and barium sulfide, barium is same. It's minus to minus, the charge is same. Now in group 6, oxygen, sulfur, Se. Oxide is small, sulfide is large. So what am I supposed to write? Oxide is smaller than sulfide in size. Oxide will attract barium more strongly. As a result, the delta H lattice is more exo. Can I repeat? Oxide is smaller than sulfide. My first conclusion. Second, oxide is attracted by barium more strongly than sulfide by barium. No need to write this thing. Like in the first statement, that it is smaller than this. So oxide attracts barium more strongly, and therefore delta H lattice would be what? More X. Now if I compare, for instance, zinc chloride with zinc oxide. Where is the difference? Is the difference in zinc? No. It's what? Chloride oxide. The charge of which one is more? The charge is more. What about size? See, 18 electron, 3 shells. 10 electron, 2 shells. It has small size, high charge. So what am I supposed to write? I will write oxide has high charge and small size than chloride. Therefore, oxide attracts zinc more strongly and delta H lattice is more X. Right? Look, I have done these questions for you so that you people can write in the perfect way, because most of you know what you people do. When I check the paper, in the like I'm talking about the mids, the mocks, the test, whatever I check. I'm teaching in a lot of schools, right? So if I'm telling you something that you people do this, then it's actually I'm telling you that कि ऐसा होता है, ठीक है? Like you people even don't know sometimes that you are wrong. You come out of the hall, of the exam hall, that the paper was awesome, and at the end you find that you are not even scoring up to 69 out of 100 to get an A. Like in paper 4, the A is at 69. This shows that you can make 30 mistakes. Then why students score C? Why students score like lower than? This shows that they make mistake, but they don't even know. And you know the mistakes types are what? Like you will write O is smaller than S. No, it's oxide. In chemistry, particle का अपना मुकाम है मुकाम. Like are you dealing molecule, atom, or ion? It's very important. The chemical bonding of the AS is the most important chapter. Moles ki tarah, moles. Like it's not necessary that the system or any system will ask question about bonding, but when you know bonding in perfect way, and when you know moles, like bonding will give you the language of the subject, like how you have to start, like which type of particles you are dealing. You're talking about cations, atoms, and ions, molecules, what to write, from where to start the statement. Like you people will say O is smaller than S. No, incorrect. O minus 2 is smaller than S minus 2. You're dealing ions, ionic lattice. Look, oxide has more charge, smaller size than chloride. I prefer formulae, but I've seen the students don't like formulae. They write the name, chloride, oxide, like they find it easy. Or maybe sometimes they write oxygen ion, chlorine ion. So you can write chlorine ion is perfect, but I think chloride, Cl minus, it's much better. So O minus 2 is more charged, smaller size than chloride. So therefore, oxide attracts zinc more strongly, and therefore the delta H lattice of zinc oxide is more exothermic. And you see that your next topic is what? Born-Haber cycle, right? Before leaving, like, subscribe, and share. Bye.